Practice OSPF. Last week, I explained OSPF, right? Single area, multi-area lab. Practice OSPF. Nobody has practice.
In my case, I just started, but I didn't finish.
So what is the AD value for OSPF, Andrew? Anybody can answer? Andrew, can you answer me?
Sorry, what's the question again?
The question is, what is the AD value for OSPF?
SPF 110.
Okay. Good. So which other table it forms? Which other tables is going to form EAGRP, sorry, OSPF? I think DR VDR election yesterday or last week I explained, guys.
Okay.
DR VDR election.
Sorry?
Clara?
Sorry, do I have what?
Did I explain about DR BDR election in OSPF?
DR BDR?
Yes.
I don't remember that. I don't think so.
Okay.
Is it the one which you are saying that it takes the one which has got highest number of the IP?
Yes. Highest priority of the IP.
Okay. I think we did that with the ERGRP.
Okay. So then we'll jump for OSPF LSA types. Okay. Because OSPF is quite very important, guys. That's the reason I'm paying a lot of attention. So I'm taking long time to complete the OSPF, because today I'm going to discuss even ESCL as well. Can we start now? I don't know. I think still many people have not yet come. Okay, so let me start the training because I could see I think Asma, she has joined, Ajay, Clara, Andrew. Was Angie also joined? Just now she quit already. Clara and Angie, she joined just now.
Yeah.
Yeah, I had a network issue, so I was put it out. Yeah.
Okay, fine, no issues. Okay. Okay, guys. So let me. I think you can able to see my screen, right, guys?
Yes.
Yeah. See, guys, like today I'm going to discuss the topic that is your OSPF. LSA stands for, guys? Any idea about LSA, guys? LSA stands for? Link state advertisement, guys. Please remember. If you want, I will write it, note it down here.
Link state advertisement.
Yes. Okay, so link state. Link state advertisement. Okay, as you know that your OSPF is your link state protocol. Okay, link state protocol. So again, we have the different types of LSAs. Okay, in OSPF that we are going to discuss now. Okay, that is a LSA type 1. So type 1 is your router LSA. Okay, so LSA type 2 is your network LSA. Okay, LSA type 3 is your summary LSA. LSA type 4 is summary LSA for ASBR. What is ASBR, guys? What is ASBR?
Autonomous system border router.
Okay. Good. So what are the 3 tables formed by OSPF, guys?
The neighbor table, the topology table,
Okay.
and the routing table.
Good. So we should discuss each and everything, guys, this one. These are the few LSA types, guys. So you should remember this for the long time. As you know that for every organizations, like most of them, most organizations, they are using OSPF, guys. Most organizations nowadays, they are using OSPF. Okay, which algorithm OSPF used, guys?
Good morning, everyone.
Good morning, guys. Who is this?
Isaac.
Isaac. Okay. How are you, Isaac?
I'm fine. Sorry for late.
Yeah, what is the reason? Why did you join late?
Because I changed the place from working area to my hometown,
Okay, you're from which country, Isaac?
Tanzania.
Tanzania. Okay, no problem. Okay, so let's back to the topic which we have not started now. Now we are supposed to start. Okay.
Yeah.
So as you know that, I think last week we had discussed on the basic concept of the OSPF, right? Some of the OSPF, how OSPF works. Okay, so what are the OSPF like configuration we made? Okay, and OSPF for multi-area also we have done, and single area, right? Okay, multi-area and single area also we configured it, like area 0, area 10, area 20, right? Like this we can create like unlimited area. Unlimited area we can create in your OSPF, right? So this is the last week what we have done in your lab, correct? So now today the topic what I'm going to discuss the OSA LSA types. So we have like 8 types of LSA. LSA stands for your link state advertisement. Okay, LSA type 1 we'll call it as a router LSA. Type 2 is your network LSA. Type 3 is your summary LSA. Type 4 summary LSA for ASBR. Okay, type 5 is your autonomous system external LSA. And 6 is for a multicast OSPF LSA. 7 is a not so stubby area LSA and external attribute LSA. So these are the LSA types. Okay, guys. Most organizations we are using, guys. So as I told you that your LSA almost or every IT industry they are using it. You know what is the main reason? Because of the scalability. Okay, there is it is an unlimited hop count, right? Unlimited hop count. Correct. Unlimited. Whereas the EHRP, guys, 255, right? And RIP is 0 to 15 hop count. Correct.
Yes.
So whereas your OSPF, okay, there is no unlimited, guys, unlimited hop count. That's the advantage. It's a huge advantage, right?
Yes.
Got it. Okay, so let's discuss some other topic, guys. Let's start the part of this one. Understood, guys? These are the topics we shall discuss now. We'll also do the lab. Okay, we'll do the lab for this for our LSA types. Okay, and after this, we are going to start your access control list. Okay, access control list. You heard about this topic, guys?
So.
Okay, this is a topic 1, and this is your topic 2 of the today. Okay, in ACL, what are the things we am going to discuss? Okay, that is your standard ACL access control list, and second one is your extended access list, extended ACL. Okay, then named ACL. So these are 3 topics we shall also discuss. And third topic will be, guys, today I am also going to do the lab for your ACL. A lot of topic, guys, because if I show you the CCNA content is very huge, guys. Okay, so maybe depending upon, because even though This is like Ramadan months, we are fasting, but still, so I'm ready to give delivery, like train for 4 hours. Is it okay, guys?
Yes, sir. No problem.
Okay, and don't tell we are tired here, this thing, okay, guys, because a lot of topic. Because you know how much time we'll give, that much we can, I can teach you guys. Okay. Okay, so let's jump for the topic, guys. What are the topics which I supposed to explain today? Okay, as you know that, guys, so these are the slides which what you can see, right? Link state advertisement. So as we can see on your screen, right? So as you know that here, what is stands for link state advertisement. So issue with the main maintaining the large OSPF network. So remember, guys, so it's not so easy because for the OSPF, because you know it is a huge network where we are going to configure, right? In the network where we have the thousands of users, we generate a huge amount of traffic. Okay, so one more thing is OSPF can be configured where there is a like users like more than 1,000, 5,000, 10,000 end user, we are generate a huge number of traffic. Yeah, the issue of maintaining a large OSPF network, what happens? There might be chances of too many LSS. We can see on the screen. So in this topology is talking about. So example, this is my OSPF area. So what we can see. So I have received too many LSS. Means each guy is communicating to each other. Okay, the shortest path first. SPF means shortest path first is running. Okay, is too often for me for the route. Okay, what this guy is saying, my routing table is too big. I'm running low of memory. What happened, guys? Because you know the reason is, so OSPF can be configured where we have a huge amount of company, as well as what happens. So each one they start. Okay, please, guys, can you mute? Someone is I'm getting interrupt here. Okay, so now what happened here? If you see the next, because there's a hierarchical structure where we can able to see this solution for this, even though we are dividing the areas, right? One area we can able to divide it. Okay, still there is an issue here. So what happened? Types of OSPF routers. Okay, you know we have the OSPF. I think last week I told you about area 1, area 2. There will be having a number of area we can have in your organization depending upon the size and capacity of your organization. So as you know that, okay, the OSPF 0, okay, area 0, 1, 2, 3, there are a lot of area we can able to connect it. I think last week I told you about, right? Okay, the router which is connected, this external autonomous system border router. Okay, there is ESBR. Okay, that is your internal router. We'll call it as your ABR. Okay, this is area 0, we'll call it the backbone area. Correct. So if we talk about so define what is a virtual link. Guys, remember, so virtual links can be configured when there is a discontinuous network. So in this scenario, as you know that, so all the routers should be connected to the area 0. Okay, here actually it should be your area 1, and here it should be your area 2. Like this. In that scenario, what we are going to do it. So when they're going to connect your virtual link, we'll connect the virtual links. So we'll take one more example. Okay, say example like you have one area, 3 area we are running. Okay, so 3 area we are running. So if it is a area 0 here, no problem. Directly they can connect it. What if area is 0 is here, and here we are running area 1, and here we are running area 2. How we are going to do it? This guy, no problem. Directly connected. He is connected to area 0. What about this guy? That's the reason we'll create your virtual link. So virtual link can be configured by giving the router ID. Router ID for this example, say example, this is my 4.4.4. Okay, and this router ID, so I can give 5.5.5. Okay, so like this, I can create my virtual link. Means they can exchange their updates. They can exchange their updates to each other. Okay, so let's jump for this one. So how to configure virtual link is very simple, guys. So creating virtual link. So just create one ID. I think previous slide I showed you about. Connect from area, which areas belongs to the ID. ID is nothing but IP address, which has got the highest IP address. That guy will become your designated router in OSPF election process. I think last week I explained you, right? Do you remember, guys? So last week I explained you about that. Understood, guys? All of you?
Yes.
Yes.
Okay. So let's jump for this one. So because the OSPF, as you know, that if it is a discontinuous network, okay, your area 0 is somewhere in the network. So we can create your virtual link by using your router ID. Got it, guys? So let's move on. So he has configured a virtual link. How to check? Show IP. We can see, right? So show, we can see show IP virtual link. Show IP OSPF virtual link. Got it, guys? So it will show you the details of the OSPF from where to where you have configured. Okay. Okay, someone asking for YouTube directly. Okay, so let's jump for this one. Okay, guys, so this is what I think we are supposed to explain now. So what are these parameters, guys? We should remember, okay, so OSPF router 1. Okay, LSA type 1 is your router LSA. So that we shall discuss step by step, guys. Pay some attention, is quite very important, guys. These all topics are quite very, very important because, so most of the organizations, all they have implemented your OSPF only, guys. Only 2 protocol, guys. Okay, so 2 or 3 maximum. So first thing is your EAGRP, okay, OSPF, okay, or maybe some static or some default, depending. So these are the protocol you can find in every organization, guys. In every organization. In every organization, they can see it. Okay, so let's do some. How does this work now? So let's understand how does it work. Say, so example. Okay, so this is my router. 2 router I have connected. Okay, this is my R1 and this is my R2. Okay, so they are, when they exchange their updates, they are exchanging their updates to each other. Okay, this is called your LSA 1. Understood, guys? And remember, for the point to point, remember this is the point to point, right? Directly connected to each other. We'll call point to point. Doesn't require to configure your area. You should not configure with area, guys. Remember. Understood, guys?
Yes.
Okay. So now the same topology I will take. So example, I will connect this one more router here. Okay. Example, this is my R3. So I will connect to these routers now. Okay. What happened if, example, this is my DR. What is DR, guys? DR stands for your designated router. Okay. When they send the update, okay, to other, say example, this is my BDR and this is your BR other. BR other means he cannot become, this router cannot become your BDR, nor he cannot become your DR router. Okay. So when you send this update, new update, okay, to this DR or BDR, okay, so now what happened? This is called your type 2 LSA. Means you are giving network update. You are giving your network update. If you talk about summary LSA, okay, summary LSA is nothing but a combination of, okay, the combination of 3 and 4. Summary LSA. The summary LSA is nothing but a combination of your LSA 3 and 4. Okay, so how does this going to work? So let's say, let's take my topology. I think topology I have not drawn here. Okay. I cannot write here. Close this. So let's take my paint. This is better. Now I'm talking about, okay, that is your LSA 3 and 4. How does this going to work? Say example, okay, this is my router 1, 2, 3 and 4. So imagine, so 4 router have connected. Okay, so this is my R1 and this is my R2 and this is my R3 and this is my R4. So now what I'm going to do, okay, so this belongs to your area 0. 0. Okay, now this guy belongs to area, we can do area, okay, area 1 or area 2. Let's say area 2. Okay, and this guy will make it your area 3. So now guys, you tell me which is ABR guys here. So this is my router, right? Which is a ABR router. This is your ABR, area border router. And this one also, we'll call it as your area border router. Fine. First, remember guys, the router 1, okay, sending to the router 2, okay, what type of a LSA type? This is the LSA type 1. That is your router LSA. You are getting any update, giving the update to the area 0 router, we will call it as your type 1 LSA. Now, so type 3 LSA, from when you received this update in area 0, in area, if you received this one, so this will accept as your type 3 LSA. We'll call, what is type 3 LSA is your
summary.
Okay, summary LSA. Same thing here also. How he has received here, here also will received as your summary LSA. That is your type 3. Means any update received, say example, you connected that one different network. So maybe new network you have connected. So here you are running 20 dot network and 40 dot network. The new network you update. Okay. So this guy, what it does, it will send update to this guy. Okay, same thing. When this guy received any update to the area 0, that will call network LSA, because area will accept this is my new network. Now, this update, it will send to the other area 0 to area 3, okay, same update. For them, we'll call it as a summary LSA. They will give only summary, not the entire routing table. The reason is, I already explained you, because, too many LSA is not good, right? Too many LSA is not good, because, the memory will increase. Your memory will get increased, and your memory will full of this lot of LSAs. That's the reason they have introduced about the LSA. What happened, man? So if you got full with your stomach, if anybody asks you to take still pizza, burger again, over and again, means you cannot take full, right? Got it? That's the reason. So it will hold, it will not take. It will take the only from the area 0. That is only area 0 can update. If any changes in your network, maybe you connected one more router here. Okay, maybe you are running your EIGRP here. Maybe you are running EIGRP. So what is this router name then now? What is the name of this router? This is the area border router, and this is also area border router. And what is this area which is connected, which is running EIGRP, or maybe you are running RIP or static, some other routing protocol apart from your OSPF. This is a OSPF. And this is what we call autonomous system border router, ESBR. Understood, guys?
Yes. Little.
Little.
Yes.
Okay. So try to understand, guys. See, because same thing. Say example, this is my another router which is connected. When these guys send the update to R1 router, okay, send the update router. So this guy will take it as your type 1 LSA, as I told you, network LSA. When these guys send, okay, when these guys send to the area 0 for this router area 0, so they will consider as your type 4 LSA. That is your, because type 4 LSA is what?
Summary.
Is ASBR. ASBR. Can see, right? ASBR. It is also summary LSA. So first understand these two, okay, LSA 4 and 5, both are summary LSA, guys. Sorry, 3 and 4. Here 3 and 4, both are what? Summary LSA. Both are summary LSA. What is difference is, so 3 is type 3 LSA. So type 3 LSA, what it does means, when any update has been generated by router 1, it will send to the router 0, area 0. Okay, that within that same area, right? Here also you are running OSPF, and here also you are running OSPF. Okay, that is called your type 3 LSA. If you are getting from other routing protocol, okay, from maybe you are running EIGRP, RIP, any static, then it will take your type 4 summary LSA. Understood, guys? When this guy has sent, okay, when this guy has sent any update, okay, it will take it as your type 1. It will receive as a type 1 as a router LSA, but forward to the area 0 as your type 4 LSA. It will take it as a type 1, it will forward to you as a type 4 LS because it has been learned from external router, from ASBR router. This is your ASBR. Understood, guys? You want me to explain once again? Guys, you want me to explain once again? Understood? So let's talk about your LSA 5. So LSA type 5, what I'm going to explain. Say example, same scenario we will take. Okay, let's take the 4 router. So each one is connected to each other now. Okay, so this is my R1, R2, R3, and R4. Okay, same thing. Okay, this guy we are running area 0, and this guy we are running area 2, and here we are running area 10. Anything, whichever you can able to understand. Say here I'm going to attach one more router. So here I'm running RIP. So what happened here, when these guys send the update to this router, okay, what happened? So this guy will learn as a type 5 LSA. Because it is an external LSA, right? What is external autonomous system? External LSA. It is learning from other area, right? It is not belongs to same area. Okay, same thing, it will forward, it will learn by using your type 5 LSA. And here also same, external LSA. All are external LSA. Because they will update themselves by seeing that, okay, there is a new guy, okay, which they are running. They are not running the OSPF, but they are running the some different routing protocol, that is RIP. Okay, they will learn as a LSA type 5, link state advertisement, type 5, that is external LSA. I hope this understand, guys.
Yes.
Okay, I think I've not gotten clearly the difference between type 4 and type 5.
4 and 5. Summary LSA, that is a summary LSA, and this is your autonomous system border LSA. Say when you connected one more router here, okay, so maybe you are running another area, okay, another area, maybe your area 20. When these send the update, when these guys send the update, okay, and this is called your summary LSA. Summary LSA. Summary LSA from whom? From ASBR router. This is your type.
Oh.
This is your type 4. Very good. Got it. When you are running different routing protocol, okay, then it will learn as your type 5 LSA.
Okay.
External LSA. Understood?
I see. Yes, I understand now.
It's very important, Clara and Angie, Andrew, Luano, Isaac. Because, you know, these OSPFs, most of the companies, they'll ask in the interview questions. The first interview questions, they will ask the basic of OSPF. What is the AD value? How does it form the neighborship? How it will send the hello packets? Right, basic things. If you answer this, then they'll jump for the ESS. I don't know in Africa how they will conduct the interview. And here interview is quite very difficult, guys. It's not easy, so easy to clear this thing. So here is same thing I explain in a very simple way. You can see type 4 LSA. What are things access? Same thing is repeating. So if you want, I will share you this slide. Okay,
all right, thank you.
It's quite very very helpful slides. External LSA. We can see same thing is repeating. If you check this one, external, right? You can see ESBR, right? The router which is connected here. Okay, let's clear this. So let's say I will connect one more router here. External LSM means what? So means I'm running my EIGRP here. Maybe I'm connecting a lot of PC. When they send the update, so what kind of LSA means it will learn your type 5, right? Okay, all they will learn all type 5. Only type 5. Means they will understand that, okay, there is one network, okay, they are not running our routing protocol, rather they are running some different protocol. Maybe you can run your RIP, okay, maybe you can run your EIGRP, okay, maybe you can run your static routing. When they send the update to you, they will learn as your type 5. We can see, right? External type 5 LS are used to advertise network from other autonomous system number. Type 5 LSA are advertised and owned by originating your EASBR. This is your it will originate to ESBR. Maybe don't think only one router. Maybe you connected one more router here. Maybe you are running a lot of network connected to here. I think these are the commands like how to, we'll do the lab now. So show IP OSPF database. You can see, I think last week I told you, right? Show IP OSPF database. Okay, how do we recognize this? Okay, OSPF means OM stands for your intra area. Okay, OIA means, okay, intra area summary LSA. OE1 is type 1 external routes. E means external route. Guys, this is the interview question, guys. Guys, please remember, this all the interview questions they'll ask for the engineers. I think some people, especially I want to emphasize some people like Asma and some TN Ranjit, Vodapalli Basha, Zoom user. Guys, please remember this all the interview question because we have to remember this. So E2 means external routes. We can see, right? Last week we did lab, right? For this one, we have noticed this all things, right, guys? Last week when you did the lab, okay, so I think we have noticed this all useful commands. So calculating cost, okay, you know, router 3 depending upon R1 calculations. I think last week also we had discussed this. Show IP route is a basic command. Okay, so we'll jump for the lab, guys, directly now. Okay, lab might be very interesting, right? So let's jump for the lab now. So I'll start my packet tracer. And you should practice every day, guys. Okay, guys. So let's jump for the lab now. Okay, so regarding the OSPF, I think DR-BDR election in last week I explained. Do you remember, guys? All of you? DR-BDR election. Designated router and non-designated router, how the election process, highest priority value became the DR. And priority value also we can give 1 to 255. That also value also we can change.
1 to 57 or 1 to 155.
1 to 255.
Yes.
Fine.
1 to
1 to 255. We can give that. Okay, so let's start jump with the lab now. So let's do your virtual link, guys. Okay, this time I'm not going to use the lot of switches and pieces, guys. So I'm going to use only the most virtual interfaces. If possible, or if I required, so I'm going to use only the virtual interfaces. Okay. So let's start with the lab, guys. So I'm going to use the router. So 4 router I use this time. So 1, 2, 3, and 4. Okay, so let's okay, what I'm going to do, I will create the virtual interface, guys. Sorry, I will add the module inside. It's booting, so let's make it off. Yeah, so I'll remove these 4. So this should be here. So I'm going to connect your serial. So let's draw some design, guys, so that you can understand like what I'm going to configure this. So let's say I will take this one as a green. So this center router, I'll put it in area 20, say example area 20. So we'll change the different scenario now. This guy, and this is my area 0.
Sorry, sir.
Yeah. Yes, ma'am.
If you want to remove the line, the wire connected, where do you place it in the packet tracer?
Okay, just press del key. Press del key, your cursor will change. You can see, right?
Okay, delete key.
Yeah, delete. Just delete it, it will go. Press escape. Again, you can be able to connect it.
Okay, thank you.
Yeah. Okay, so let me put it on the label here. So I'll put area. This is my area 20. And I'm going to give this IP address 1.1.1.2/8. And this is 1.1.1. So very simple IP address I'm going to give guys. 2.2.2.1/8. This is 2.2.2.2. This is class A IP address I'll use. So here I'll use 3.network. 3.3.3.1/8. Okay, so this I'll give 2. And this I'll put it in, this is my area 0. Okay, this is my area 0. Okay, and this is my area 10. Means this is my main network, guys. Okay, so here I'm not going to create any network, guys, because rather than I'll use loopbacks. Okay, you should understand, guys, don't get confused. Okay, just we are doing the lab for testing, so I'll use just loopbacks. Okay, so which are the loopbacks I'll use? Say example, for your understanding, most of the things I'm using class C, right? Got it. So what I'm going to do, so I'll use the same, I'll use this time 11 network, okay, 11.0.0.0.1, because I'm going to share this topology, right? So I'll put it in class C only. Okay, then 11.0.1.1/24. Okay, 11 dot, I'll use 0.3.1. This is my /24. Okay, so here what I will do, same thing, I'll copy this one. So here also I'll paste, just I will change to other network. So example, I'll give this 10.14. You can use your own IP address. It doesn't matter, guys. It's not matter. We can give your own network, no issues. Okay, so here the fast Ethernet, I think we are not given an IP address. For the fast Ethernet for gigabytes, for these, let's say we'll give 10.1.1. This is my /8, and this guy, let's put, this is my inside network, man. This should be the inside network. So here this area 10, okay, I'm running only these loopbacks for 3 network I'm running. Okay, and this is the IP address which for the fast Ethernet. Okay, so that is a 10.1.1.1. Okay, for this network. Got it, guys? Okay, so let's do this. So what is the first scenario we should do guys here? This is OSPF. Virtual link configuration. Let's make it zoom. I think now it is visible, guys, for you.
Yes.
Because I make it too big topology. Okay, these are 3 network I'm running here. So here I'm running in this network, I'm running 3 network. Okay, so we are going to configure your virtual link. So virtual links, how we have to configure that? First understand. So we are going to connect this virtual interface because so all these routers should be connected to area 0. Remember. Yes.
Mahesh, your camera is on.
Who?
Mahesh.
Mahesh. Okay, no problem. Let them on the camera. No issues. Okay. So what is the first thing we should do, guys? Here. Clara, what is the first thing we should do here? And this one gigabytes, we shall give, say, example 20.1.1.1/20. And this guy also will give 30. What is the first thing we should do, guys, here?
Configure the interfaces.
First thing is we should configure with the interfaces, right?
Yeah.
Okay, so let's configure this. Okay, no problem, right? If I go first understand, guys. So what are the things what we should configure here? First, we should assign the IP address. So first, I will go to this first router. Okay, so remember this is my R1, this is my R2, and this is my R3, and this is my R4. So what I'm going to do? So first, I'll assign these all interfaces for this serial, and this for the fast gigabytes Ethernet, this interface, and this IP address for this serial, and this IP address for this serial interface. Okay, and this IP address for this, and this IP is for this. Okay, then I will create the loopbacks. Okay, 443 loopbacks here in the router 1. Remember, this is my area 20, and this is my area 10, and this is our area 0. So in the virtual link, guys, okay, you will not receive these updates in this network. You can see only these updates in this router, in your router 4. Okay, that's the reason we are configuring OSPF virtual link. We can link with this router to this router. So this router, we'll call it as, what is the name of this router? ABR, right? Area border router. What about this router, guys? What is the name of this router?
ABR.
Isaac?
ABR.
ABR or ASBR? Asma, can you tell me? Are you there? Asma?
AS.
It is a ASBR? Asma, can you tell me?
Yes, it is ASBR.
It is ASBR? Angie?
I think it's also SPR.
It is ASBR? No, guys.
I think it is external border router.
These all are, this router is ASBR, Autonomous System Border Router. Area border router. This also area border router. ABR. Sorry. These all are ABR. This router also area border router. Now, who is ASBR now? Question
Router
mark.
0.
Router 0? No, man. How it is router 0? That is the area 0 itself. I told you that, okay, when you are running connected to the other router, okay, in this router, okay, you are not running OSPF, rather you are running EIGRP or RIP, okay, and this router for him, okay, we'll call it as your ASBR. Now it will become your ASBR. And this guy is saying, this is area border router. Understood, guys? Maybe you are running one more router here. Maybe new department has been introduced, say example, your cyber security department, new department. They are running a lot of network now, which does not belongs to this area. So now this router will, what will happen? This will call your ASBR, Autonomous System Border Router. Understood, guys? Don't get confused. If it is OSPF, all we are running OSPF, right? Here also we are running OSPF. Okay, here also we are running OSPF. Okay, and here also we are running OSPF. Correct? If it is OSPF means all will be, you can find only ABR. You cannot find ABR. We can find ABR when it is connected to other router which is not running your OSPF. Which is not running OSPF. Understood, guys? Don't get confused.
Yeah, now it's understood.
Yeah. So can I move for jump lab now? So let's do the configuration part. Okay, I'll jump for my router 1 now. So enable. So this is my router 1. So first thing is what I am going to configure. First, I am going to configure the serial interface. Okay. So interface serial 0/1/0. Right. So IP address 1.1.1.1, because I have given very simple IP address, guys, just to remember. Because I don't want to give a long, lengthy IP address like class C. Okay, 255.0.0.0. The class C IP address is very simple to type, right? Okay, as you know that, so we can see the clock rate right here. We can see the clock rate. Means you have to set the clock rate. So clock rate, so I will give 65,000. I'll give no shut. Okay, I'll say exit. Okay, I also give gigabytes 0/0/0. The IP address I'll give 10.1.1.1 255.0.0.0. I say no shut. Right now it is not connected to any PC. Like if you want, we can connect it. So after that, what I'm going to do, I'm going to create the loopbacks. So how many loopbacks we have to create? I'm going to create your 3 loopbacks. So IP address 11.0.0.1, okay, /24 means what should be my subnet mask?
255.255.0.
Yes, very good. So I can create the loopback 2 now. So here I'll create one more network. So loopback 3. So here I will create loopback 2. So it should be 2 there, because don't get confused here. Let me write it down here. I will change to 2. It starts from 0. Yes, so let's see. So and show IP interface brief. So as per the topology, what we have done, so we have done this all. Why it has created only 2 loopback? 0, 1, 2, 1. Okay, one more loopback we are not expecting. The interface loopback, loopback 3. IP address 11.0.3.1. Let's say, because here we has taken already. Okay, so these guys still is not up because we have to give this IP address for this interface, right? So we have to give the IP address for this interface. Okay, so now loopbacks has been created, and this is also down because we should give up to this interface. So right now I am into router 2. So configure host name R2. So I'll configure with interface serial 0/1/0 IP address 1.1.1.2, right? Okay, so I say no shut. So now interface is up now. So interface serial 0/1/1 IP address 2.2.2.2.1. Give the mask. Okay, so clock rate, you can see the clock rate, right? So then I should give an IP address now for gigabytes. Guys, is it I'm going fast? Just I'm assigning the IP address, nothing I'm doing it. Done, guys? So here I'm not going to create the loop back, guys. Okay, because we are creating just a OSP virtual link configuration. Okay, so let's go to my router 3.
You're in router 2.
No, now I'm router 3 now.
Okay.
So host name, and this is my router 3. Go to serial interface 0/0. IP address is 2.2.2.2 and give the subnet mask. So I say no shit. Now interface is up, right? Okay, now serial 0/1/1. The IP address is so 3.3.3.1 and give the subnet mask. So give the clock rate for this. I'll say no shit. So do show IP interface brief. So right now we can see just we assign the IP address as per the topology. Got it? So as per the topology, so we have done the configuration. Just we assign the IP address for serial and 2 serials. Okay, so now I'm in R4 now. Okay, this is my router 4. So router 4, so first go to serial 0/1/0. IP address is 3.3.3.2. Correct? As per the topology, that's the reason I'm putting the label for each interface. Interface name and IP address. I say no shit. Okay, so then in interface gigabyte 0/0/0. IP address 40.0.0. Sorry, I think 40.1.1.1. I think 40.1.1.1. Okay, 255. I say no shit. So now I'll create the loopback. So how many loopbacks I have to create here? So 3 loopbacks I'm going to create now. So interface loopback 1. So IP address. So 14.0.0.1. Okay, so /24 means it should be 255.255.0. Got it. So loopback 2. The loopback 2, I am going to create 1.1 different network and 3
Back 3.
loopback 3. Done. Show IP interface brief. Okay, so all interfaces are up now. We can see. So all interfaces are up. So everything is just we assign the IP address. Nothing we did, right? We are not configured anything yet. Remember, guys, we are not configured anything on the routers. So can we start doing, guys, now? Let's start first from OSPF configuration on your router 1. So if you type show IP interface brief, you can see these all interfaces are up. Guys, can you tell me why this interface is down? Who will tell this answer? Why this interface is down?
Because you are not configured it.
So what I have to configure here? Is it
Virtual.
Andrew? Is it Andrew, right, or Isaac?
VLAN. Virtual.
Reach. Okay. Okay. What I should configure here? Because even if you check in this here also, show IP interface brief. So here also it will show you down. Can you see?
I think it's because it's not connected to any other device.
Yes, very good, very good. Means if you connect any end user devices or switch, okay, so it will up. And here as well. If we connect these, so let's say I'm going to connect this one. Now we can see, so it will be up. This is the IP address for this guy. This is the IP address for this guy. And let's say, and what is the IP address for this guy? Is 40 network. So this guy is 40. Okay, guys. So we can see up, right? Now it will become, if you type once again, so now it is up. Can you see? Okay, so let's configure, guys. So what I'm going to do, guys, so let's configure the OSPF first now. First, remember, so this all network, 3 network, okay, all belongs to your area 0.
So,
Okay,
but before we proceed,
yeah,
on router 2, no, router number 3, the laptop interface is too down.
yeah. I think for here, we are not given the IP address. Show IP interface brief. Yes, very good. Okay, we are not given the IP address for this interface. Okay, let's give that. So interface gigabyte 0/0/0/0 IP address 30.1.1.1 So now it is up, right? Fine. Let's put it this guy here. Put this laptop up. Virtual link should be here, yeah. Sorry, guys. Yeah. So right now I'm in router 1 now. So I'm going to configure the OSPF now. First, remember in router 1, so I should configure this all 11 network to area. Which area I should configure? I should configure in area 10, right? So let's say router
1.
Router 1 or router 2? I can give
You're
any.
configuring the router 1.
Yeah, I'll give OSPF 10. Okay, then I'll give the router ID, so that is quite very important, guys. So router ID, we can give the IP address. Okay, so let's say I'll give 11.1.1.1 because I'm going to connect these 2 virtual interface. Remember, what is the objective this one, this lab is, so I'm going to connect these 2 to each other. Then only, so this network I can get from to your area 0. Same thing, this network I can see in this router. Got it? So that's the
Can you
reason.
repeat?
Sorry?
So you want to check the network of 11.0.0.1 into router 2.
This is the router ID I'm creating. What I will do, so router ID I will create first. For these, I will create router ID.
Yes.
Router ID is 11. I'll say 11.1.1.1. Okay. So here I will create router ID. Okay. Router ID I will create say 33.1.1.1. Then these 2 I will connect it to each other. These 2 I will connect. This link will call it as virtual link. Then only this network I can see in router 4. Okay, and router 4 network I can see in your router 1. Otherwise I cannot see. Okay, so let's do that. So I am doing this 11.1.1.1. So now I'm going to authorize my loopbacks. Which are the loopback? 11.0 my 0 network. Okay, I give the wildcard mask 0.255.255.25 and belongs to which area? This area belongs to which area, guys? We can see the topology, right?
It's area 10.
Area 10, right? We can see the topology, right? Area
Yes,
10.
we can.
Yes. No. So now which network again? Network. One network, right? 1.0.0.0 belongs to area. Which area?
0.
No.
Is that area 0? Can you move
See
the
the diagram.
Yeah.
It's 20. Area 20.
Yes. It's a 20. Then which network again? Any other network? Network 10 network, right? 10.0.0.0 255 255 255. And this also belongs to area?
Area 20.
Yes. Good. Done. Router 1 job is done now. Now I am jumped to the router 2. So I'll enter to the global configuration mode. Okay. Router OSPF 10, because it should be same, right? The process ID.
Yes.
Okay. So now I will advertise my first one network 1.0.0.0, then 0.255.255.255, and area belongs to 20, right? And one more network is 20. Okay, one more network is 20.0.0.0. Okay, and then give the wildcard mask. Okay, and these are belongs to my area. Which area? 20. All are here. It belongs to area 20 only. Remember, guys. These all people are belongs to your area 20. Okay, and one more network, 2 network, right? 2.0.0, which is connected for R3. 2 network, guys. What is the wildcard mask for this? And this also area 20. And loopbacks, I don't want to get, we don't have any loopbacks here. Or else this other method also we can configure the OSPF, guys. Let's say network, any mask, any wildcard mask, okay, and area 20. The new command. So this way also we can configure, because when it is this all network, how many are there here? Network. So this is my network 1, 2, and this guy is 3. 3 network. If the 3 network means just say any network, any wildcard, and put it into area 20. Alas, network. Got it, guys? Like this also we can configure. The other way of configuring your OSPF. Guys, you are following me?
Yes.
We are following.
Yeah. So now I am in router 3 now. So router 3. So I'll router OSPF 10. So I will create my router ID here. Router ID, what I have told you, 33.3.3.3. Okay. So now I will advertise my network, that is 2.0.0.0, which is connected to my R2. Okay. Then 0.255.255.255. This belongs to my area 20.
20.
See, is loading, right? So network, then 30.0.0.0 network, 0.255.255.25. And this also belongs to my area 20. And one more network, that is 3.0.0.0, 0.255.255.255. And this is belongs to which area? 3
Area 0.
area?
Area 0.
20.
Area 20 or 0?
Area 0.
Yes, area 0. Okay, so this is done. If you type show IP route OSPF, so I think this guy has learned 1 network, 10 network, and 20 network. Perfect. So we are going on the way, correct? Perfectly we are configuring. Now router 4. So router OSPF 10. So because remember guys, when it is in a single area, okay, 3 network and these all networks. If it is same area, all network belongs to the same area, very simple command we can give network, any mask, put it in area 0. No need to configure individually. Okay, to avoid confusion guys, better to I will do it individually guys, because you will get confused, right? So let's configure which are the networks available here. 40 network.
40 network.
Okay, what is the wildcard mask for this?
0.255.255.
And area 0, correct? And network 3 network 3.0.0.00, 0.255.255.255, and area 0.
Sorry, sir. Where did you get the network ID? 40.
Sorry,
That is network ID 40.0.0.
40.0.0.0.
Network ID in the router 3, router 4.
Yes, this is the network ID.
Oh, the diagram, I didn't see the diagrams. Sorry.
Yeah. 40.0.0./8. And this is 30 network. This is 10 network. This is 20 network. This is 30 network. And this is 40 network.
Okay.
Yeah. So 3 network, 40 network, then what else? 14 network, 14.0.0.0, right? Loopbacks. Correct. Okay, 0.255.255. Okay, is it correct, guys? 255.255.
255.
No,
And
it's not correct.
Has to be 0.0.0.255.
Because we have given for the class C, right?
Yes,
Yes.
it's a class C.
It should be 0.0.
0.255.
Is it correct, right? Area 0. Done now? Everything is done? Okay, so let's check this one. The show IP route. Show IP route OSPF. So what did you notice, guys, here? IA means inter area, right? Inter area means it has learned 1 network, 2 network, 10 network, 20 network, and 30 network. Means in this, he cannot see the 11 network. Apart from these, he has learned everything. Got it? If you check, I have checked in this router, these all network are available. 3 network, 2 network, 30 network, 1 network, and your 20 network and 10 network. And even 10 network also available, but not this. Okay, that's the reason we are going to do the virtual interface. If you check in R1, let's check R1. Show IP route. Show IP route OSPF. See, this guy has learned already. So you can see, right? 40 network. If you ping from here, inter area, right? Let's say example, 14.0.0.1. There's no communication.
You put 140.
Instead of 14.
We have the communication, right? 0.1.1. Loopbacks. We do have the communication. 14.0.1.1. 1.1 is not there. I think 14.0.3.1. Okay, for that, what we are going to do, so it's not showing. So we'll configure the virtual configuration, guys. If you check this all, router 1, router 2.
Configure the virtual network.
Huh?
Why is it that from router 1, we're able to check, I mean, in fact, it has learned the loopback from router 4. Unlike router 4 has failed to learn the loopback in the router 1. Why is it in that way?
Show IP route. See, this guy has learned what? What thing this guy has learned? IA network. Okay, he has learned other area network because it is other area, right? This other area network he has learned 1 network, 2, 20 network, and 3 network. We can see, right? 3 network he has learned. 10 network also he has learned. 30 network, 20 network. Okay, whereas in R2, if we check in R2, show IP route OSPF. So router 3 has learned 3 network, 10 network, 40 network, and 40 network from another area. Okay, now how do I check? Let's say example, I will give some very troubleshooting commands. Okay, so we can see there's a no route for 11 network. See, can you see the 11 network here? Can you see? We cannot see, right?
No, it's not there.
11 network is not there, right?
Yes, it's not there.
Yeah. So see, there's a lot of troubleshooting command, guys. Please remember this. Okay, show IP protocol. If you type this command, okay, we are running the OSPF 10, okay, with the area 10 and area 20 in this router. Okay, area 10, 11 networks are running. Okay. So what is the router ID we are using? The router ID is 11.1.1.1. Got it. So these are the 3 networks he has done. Distance is 110. What is this 110?
OSPF 30.
That is the administrative distance for the OSPF. Right. But this guy has learned this one. If you check in R3 now, show IP protocol. So this guy, okay, so the gateway he can see, the gateway has connected 14, 20, 30. You can see. So now what we'll do means just we'll connect the virtual interface. How do we connect the virtual interface? It's very simple, one line command. So go to global configuration mode, router OSPF 10. Okay, then area. So which area you want to connect? I want to connect to area 20 with the virtual interface, with the virtual link that is 33.33.3.3.3. That's it. Fine. From R1. From R3 perspective, so what we should configure? Router OSPF 10 received invalid packet mismatch area data. Can you see it's showing, right? Error. We should configure that one. Area 10, router OSPF area 10. So now what we have to configure? Area 20, virtual link to which interface? 11.1.1.1, right? if you type and show IP OSPF neighbor. Now it is loading. Can you see? Now LAN network also is showing my neighbor in 11 network. Can you see? VL means what? What is the meaning of VL? What is the meaning of VL, guys?
Virtual link.
Yes, virtual link. Show IP OSPF neighbor. So we can see, right? He has created a virtual link. Understood, guys? So this is how we can create your virtual links.
So can you come back on this creating a virtual link?
Okay. So let's check the router 4 now, whether we have received all the updates or not. So now we can see all the updates. The previous table was this, right? So now we can see all the updates we have received. We can see the 11 network as well now. Correct. Like if you want to take a show the command that is show IP OSPF virtual links. And not here, I think, router 1. Show IP OSPF virtual link. We can see, right? Virtual link is your VLO route to 3.3.33.3.3.3.
Sure.
Yeah. So here also we can check show IP OSPF virtual link. So there we can see your virtual links. Adjacency is fully formed. It has taken 9 seconds. Okay. Hello time is 10 seconds. Dead time is 40 and wait is 40 and retransmit is 5 seconds. Understood, guys?
I just want you to repeat, especially on the configuration.
Okay, where you want me to repeat?
How you configured the virtual link on both routers. I just want to see the configurations.
Yeah. So show run. Okay, so this is the command what I have given. That's it.
So
Okay.
if you're in area 10,
Go to OSPF router 10 global configuration mode. Area 20, you want to connect to the area 20 with the virtual link with the router ID. 33 is which one? This guy. Let me explain you here.
yes.
Okay, this is my R3. Okay, this is my R1. So what is the router ID we have given here? 11.1.1.1. And here, what is the router ID we have given? 33.1.1.1. You have noticed, so these network we can see here, but this area 10, the loopback which we have created 11 network, so we are unable to see this network in your router 4. That's the reason what we are doing. We are creating virtual link. This is called your virtual link. What we are connecting? We are connecting this router ID to this router ID. Okay. They belongs to which router is belongs to which area? Belongs to area 20. We are connecting like this. We are creating separate tunnel. This is called your VLO. We can see on your configuration, right?
Yes, we can see.
Understood, Clara?
Yes.
Can we jump for next lab?
So it cannot be possible just to connect from router 1 and router 4 directly?
you can connect it. Okay, this is a scenario where it is we can configure if it is a disk contiguous network. I told you, right?
Yes, I say.
Okay, maybe I think you have one area 0. Okay, we have a lot of routers connected. They are belongs to the different area. So here also you are running a lot of network, right? So each one belongs to the different area. Imagine, so these people are belongs to the different area. Each one is connected. Now, this my network, okay, this is my area 0. They are belongs to area 10, 20, 30, and this is 40. Now, the scenario where you require this guy, okay, so this guy, you want to connect to this network, not to this all people, because, you know, a lot of your LSA update will come, right? Your link state update, a lot of too many LSA is not good, because, you know, it consumes your hardware resource of your router. It consumes more hardware resource, your RAM, memory, because, you know, your router will make a lot of noise if it's too many LSA receiving from your DR and BDR. So then we can create, see, we can create this like using 44.1.1.1 by giving the router ID, IP address, and this guy will make it as 11.1.1.1, and we can create the virtual link. How we can create? Area 0, okay, and network is 1.1.1.1. The command which is already showed to you, right? Command. Area 20, virtual link, and your IP address. That's it. Nothing else. Same thing, you can check here. Okay, show run. Same thing you can see here. I have created the router ID here. Okay, so like this we can configure, guys. It's very simple command, just one line command.
It's understood now.
Understood, right?
Yes.
Okay. So can we jump for next topic, guys? So meanwhile, I will share you this file, guys. Otherwise, it will be problem. I have not yet saved. This is OSPF lab. I'll write short form, guys. VL means understandable. Okay, VL means virtual link lab. Let's give the commands. You want me to send right now, guys, this file? It could be better, right? I will send you this file, guys.
Okay.
Where is that file? OSPF. Yeah. Okay, so you can download now from your lab. Lot of topic is there, guys. I don't know how long it takes. Again, today I want to start with ACL, NAT, network address translation, PAT. We are lagging like anything, guys. So now I'm going to start the ACL, guys. So how many people are familiar with the ACL, guys? What is ACL? Any idea? Any idea about ACL, guys?
Access control list.
Okay, you are
It's
googling.
like
You are googling, Andrew.
No, I'm trying to explain. Access control link is here. Two access, door A and door B. US room 1 and room 2. But you want to allow some
Okay.
students or members. The network is very low on my side.
Yeah, no problem, no problem.
Should I continue?
Yes, no problem.
Okay. So
Stop and
two participants X and want to allow.
We are getting interruption, man.
Okay.
I think it's difficult because of less bandwidth from in your country. I think you have very less bandwidth. Okay, so access control list is a basic level of security, guys. Okay, so where it will minimize your traffic. So as we can see on the screen, okay, so why use access list? Manage IP traffic as a network access to the across the interface or in the network. This is will also use for your basic security. By minimizing unnecessary traffic generated in your network. This is the one advantage of. Okay, it also does your filtering the packet as they pass through the network. There is an advantage, guys. So why access list? If we talk about why access list, so access list condition that apply to the traffic traveling across your router interface. So it tells the router what type of packet to be accept or deny, depending upon your conditions, whether you want to deny, whether you want to accept, okay, or deny based on your specific conditions, like what kind of conditions you want to deny or block. Okay, so ACL can be configured on router, okay, to access control to a network with a subnet also. We can subnet even for the entire network also. We can block, deny based on services. Also, we can do it. Some ACL decision point to the source and destination address protocol and upper layer port numbers. It also based on your services, based on your port number as well, your ACL. If you talk about this thing, the reason of creating ACL, as you know that, so the following some of the primary reason, it limited the traffic, guys, which will increase your network performance. So unnecessary people, they are generating the bandwidth, okay, by downloading, uploading in the organization rather than working for company. So we can block them. We can block them based on the port number, based on the services. Like we can, it acts as your traffic police, guys. So which people you want to block, which people you want to allow. Okay, if it is a VIP car, you should allow, right? Okay, if it is like ordinary public people, okay, depending upon the traffic guy, police is going to manage the traffic. Same thing here also. Whether you want to forward the traffic, you want to block on the router interface. For example, permit email traffic on the router, block your telnet traffic. So example, okay, this is my router, okay, which is connected, few of my laptop or some PCs connected. For example, this is my ISP network. So I can able to send my email. When I try to access my router by using telnet, so I should be blocked. but I can send a email. This is nothing but your service-based. Like service-based or your protocol. Understood, guys?
Yes.
So again, yeah. So again, your ACL, if you talk about the ACL, guys. So ACL can be configured where? So different types of ACL available, guys. So you can see standard, extended. Now again, they have introduced again named also. These are two types of your ACL. So if you talk about the next slide, so your ACL can be in this fashion. Say example, he has given some example. We can block any one of the PC, guys. Which one you want to block to access this network, or whether you want to access this network. Okay, whether you can able to access this network. We can block or deny. And good thing is we can able to configure in your Cisco packet tracer. This is a very good advantage. If you see how it look like the IP packet for this one. Okay, so you have the versions, we have the headers, your priority bit and services, what you want, what kind of bit you want to block. Service base also we can block your based on your protocol, based on your IP address, based on your port numbers, and total length, identification, your flag bits, your fragmentation, time to live. I think you might know about TTL. And which protocol, based on the protocol also we can block, like your ICMP, SMTP, FTP. We can block these services for the user. Same thing, source IP address, destination, option, and data. So first 2 bits with TCP UDP headers belongs to source port number. First 2 bytes for TCP header belongs to your destination port numbers. I think port number, I think I told you, right? Do you remember, guys? The port numbers. The standard access list, guys. Check from the source, permit or deny the entire protocol suite. Whether we can block your PC, okay, to access your any ISP or any other network, or we can block the PC, or we can allow. Only 2 things we can do it. In which protocol? In which in standard. In standard ACL, whether we can permit or block. 2 things we can do it, guys. That's it. Remember, guys, for the standard access list, so right now we are using 1 to 99 condition to apply all the IP packets from source address. For extended, 100 to 199. Remember, right now we are dealing with only 2, guys. That is standard and extended. We'll do this one. So remember, so this 1 to 100, the router will understand that we are going to configure your standard IP access list. If you give 100 to between any one number, between any one of the number, your router will understand that, okay, you are going to configure your extended access. This is the extended access list. Your IOS is going to understand. You know, right? IOS, Inter-Network Operating System, which is the operating system for your router and switches. For if you talk about standard, still extended range from 1300 to almost 2000 and 2000 to 2699. So right now we are not using these 2. So this is sufficient. In the lab, we are going to use these 2. So configuration, guys. So we'll do the configuration now. So standard access list 1, permit, okay, deny this network. Okay, and permit 1 and permit 1 access list this one. Like this we can able to configure, guys. Same thing if you check for wildcard, guys. I think wildcard, you might know about wildcard mask. There are many ways to configure the ACL, guys. So whether you can configure like IP address permit with this network and wildcard mask, or we can give permit any, or else we can give access list 1. 1 means what does it indicate, guys? 1 means what does it indicate? We are going to configure your standard. We are going to configure your Standard ESU.
Standard.
Okay. We'll do the lab because ACL is quite very interesting, guys. We'll do the configurations. Access list 99, deny 1 IP address. Deny 99 means still standard access list. We should remember just creating the access list. So let's say he has given one example how to configure your standard access. Let's understand this. See, guys, we can see. So let's say. So I will take this. Now, account should be denied to access the sales. Means this is my account PC, guys. This is my account PC. And this is my sales PC. So they are running the different network. We can see they are running like 0.18 network. And they are running in different network. They should not communicate to each other. Means account should be denied to access the sales. Means when this guy is coming to access this PC should be blocked or denied. Understood, guys? This is the scenario, guys. The scenario is when PC B try to communicate with PC A, it should be denied. This is the lab, guys. We'll do the lab right now. Do you want break, guys? How many of them don't want break, guys? This is the scenario, guys. The scenario is when PC B try to communicate with PC A, it should be denied. This is the lab, guys. Yes, are you there, guys? We'll do the lab right now.
Yes.
Do you want break, guys? How many of them don't want break, guys?
Sorry, sir.
The scenario is when PCB tries to communicate with A, it should be. Guys, do you want break? Yes or no, man? We'll do the lab right now. Yes, you want break?
We can have a break.
Okay, then we'll take break. So we will back in 15 minutes, guys. Okay, write it down.
No,
Okay, so let me. I'll write it down here. Break, guys, because I'm fasting. I cannot take any tea, coffee. Just for you people to change your mind, I'm giving 15-minute break for tea or coffee. Let's display this. So we'll see you after the 15 minutes break. Okay. Dawara, are you there? Dawara.
Yes, sir. Just joined, sir.
Oh, on your camera, man. I want to see you. I want to see your beautiful face. Oh, man. After a long time.
Yeah, very long time, sir.
Very long time.
Yes, yes.
How are
So
you?
I'll
How
be
is
back
your
in
family?
15 minutes.
Yeah.
I'll be back in 15 minutes then.
Then fine. We'll talk later. Okay. Okay. Okay, guys, I'm back now.
Okay.
So let's do the ACL, guys, because guys, the lab which a lot of labs I had to explain you guys regarding the OSPF. That is OSPF strub, okay, not so stubby area in OSPF, okay, total stub. So these are the lab guys which I had to we had to do it. So after that, again, you people have the IP V6, okay. So in OSPF version 3. So right now we are learning OSPF version 2. No difference, guys. Just IPv4 configuration, IPv4 addressing. We'll call it as the OSPF version 2. Okay, and OSPF version 3 is something about your IPv6 configuration. So this thing we shall discuss later, guys. Still a lot of pending syllabus is there, so it takes a lot of time to explain. Let's see. Okay, so how many people are there active now? All people has come, guys.
Yes, I'm here.
Oh, Dawara.
I'm back.
Okay, Angie
I'm
came.
back too.
Okay, Akila joined today. Asma, Akila. Okay, Sahil Gani.
I'm back.
Yeah, Sahil Gani has to say hi. Okay, guys. So right now, because topic is still a lot of topic, guys, I need to explain. Because some basic configurations I'll not do, like assigning the IP address. I think you're familiar with those topics, right? The basic configurations like assigning the IP address for interfaces, okay, for LAN interface, for the WAN interface. The basic configuration, I'm not going to do that. Rather, I will use the existing topology, which is ready-made. Just we'll configure the topic as per what I have been taught to you. So as you know that today, just I explain the access control list. Okay, so this lab, I will do it right now. So I have done the previously to the other batch. So let's say standard ACL. Yeah. So what I'm not using this one. So what I will do rather than, so I'll close this. Just I'll copy and paste in that lab. I think you know, right, how to copy paste, all of you, right? Okay, so I think let me close this. I'll open once again. Just I'll delete this just to avoid the confusion. So, okay, guys. So let me make it bigger. First, understand the topology, guys. Okay, so this is the standard access list, guys, which is there on your screen. All of you can able to see the screen, right?
Yes.
Yeah. See, first understand the logic here. What I am going to explain, I am going to explain over your standard access list. So first understand. So what is the concept of standard access list is? Okay. So the range is standard access list is
1
to 99. Standard ACL should be configured nearest to destination. Remember, this is quite very important. Nearest to destinations. So this is my R1 and this is my R2. Okay, so two routers I'm using it now. So I am going to configure the standard access list. So this is all the IP address which is already configured everything. Okay. So now before configuring, guys, we should configure any routing protocol. So I think here I configured your static routing as. The static routing I configured. Okay. So what I'm after this, what is the objective here is, okay. So objective is, so this PC should not able to access this all network. We should block this guy to access my network. Got it, guys? Or else we'll use the new topology, okay, just to avoid the confusion. So it takes a lot of time. The other reason I've taken this one. So it could be better to, because, you know, it. I will take new one because, you know, you people just prefer for new topology, right? Okay.
Okay.
Because, you know, no new topologies gets, I will use routers now. This is my router 1, 2, 3 router. I will use it. Okay. And 3 switches. Oh, sorry. So I'll use the 3 switches and end user devices 1, 2, 3, 1, 2, 3, and 1, 2, 3. I'll not use any laptop and PC, guys. I'm not going to use that. Just I'm giving connections to the end user devices. Even I'm not using serial interface, but you know, one of the router I must use the serial interface to connect because you know I'll not find any other physical devices. So what I will do, I'll add one module. Okay, so then I will delete this middle link and I will add my serial module. Oh, here is not there. So here what we can do here also, we'll delete this one. Okay, you know, we'll copy the same one. So now I think I can able to see. So remaining thing will give this auto connection. You can design like however you want, man, because you know, I'm not in good in design. You design like however you want as per your these thing. Okay, so now I will write it on the content here. So this I'm going to configure your standard ACL. So let me write it down. What is the objective of this standard access list? What we are trying to do this here. So I will write it down some content. So let's say task. Okay, the first task is what I'm going to configure. So deny, okay, one of the PC. Say example, this is my 1.1, this is my 1.2. Okay, this is 2 network. So before the writing a task, let me write it down. I will write the only network ID, guys. This is 192.168. This is 1.0 network /24. And this network is my 2 network. So this is my 2 network. And this is my 3 network. Let me write it out this way. Okay, let me write it on some IP address for these guys. Say example, this is my 1.1 and this is 1.2 and this is 2 network and this is my 3 network. So we can give better to give one individual IP address. It could be better. Say example, this is my 3.1. This is 3.2. This is 3.3. I'm just assigning the IP address, guys. 3.4. Yeah. So let's say we'll set up some task here, what you're trying to do. So deny the host. Okay, say example 192.168 1.1. Sorry, 1.1. I'll make it big. It is visible for you guys. To communicate with 192.168 2.0 network. This is the first task. Okay. The second task is the same. We are going to deny 1.2 also. 1.2 to communicate your 2.0 network. And third task is so deny. So deny the network, say 192.168 3.0 network to communicate with 2 network. So this is the task, guys. So let me make it bigger. I think now it is okay, right? Okay, guys. So let's configure the basic configurations. What are the basic configuration you must do, guys? Here. Anybody want to do this lab, guys? Just assigning the IP address. Nobody is accepting my challenge, guys. You are getting scared of me or scared of this topology, guys? So interface gigabyte 0/0/0 IP address. Say what should be the IP address? Say example, this guy, I will take 10 network. Okay, so 10.0.0.1 255.0.0.0. Okay, say no shit. Okay, then interface gigabytes 1 IP address 192.168 1.1. Okay. No shit. So now router 2 power on. Okay. It's loading. I think we have forgot to on. Let's see these guys on. Yeah. Let it boot. Okay, this is my router 2. So interface gigabyte 0/0/0. Here address 2255 dot interface series 0/0. IP address 20.1.1.1. Interface gigabyte 0/0/1. The address 192.168.2.1. Okay, my router 3 now. So interface serial 0/1 IP address 20.1.1.2. Guys, is it I'm going correctly? Is it I'm doing any mistake?
Oh, it's okay.
Okay.
Yes.
Is it I'm going fast?
The speed is fine.
Speed is fine.
Yes.
Can I increase my speed?
No.
I think you should keep up with that speed.
Okay. So just now what I did, just I assigned the IP address for the interface. Okay. And IP address like for end user devices, better to give manually. I don't want to configure the DHCP. So this guy is 1.2. Okay, this is 1.1. Sorry. See 1.3 and gateway is same, right? So 92.168.1.1. Yeah. You must have a lot of patience, guys, to do these labs. Correct? It takes such a long time, right? 2.2. I'm copying, pasting. Still, I'm doing smart work, right?
Yes.
But still, it's taking time. For you people, I'm doing, guys. Otherwise, I would have taken the previous topology. I just remove the ACL. I'll configure your access control list directly. Just to make you understand, I'm doing this for you guys. This is 4. Okay, so now this is a configuration now. So what is the first task, guys? We should do now. So first thing is we should configure your any routing protocol. Let's say I'm going to configure the static routing. Fine. So now tell me how many network are there here. So here is my 1.0.0.0/8. And here is 2 network. How many are there? Network here? Totally? How many are there, guys? 5 network, right? Okay, let's see what is the objective for this lab now. What I'm trying to do it here. So let's do this. It has become so. Okay, so let's put it this guy. So this is 1.1. So what is the objective of this, guys? I'll put it color so that we can understand better. Okay. So what I will do, so I'll put it in some red color to denying PCs. Okay. So 1.1 should not communicate to, this is my 1.1. Fill with color. This is my 1.1.
That PC is 1.2. I think 1.1 is on the GI on the route.
Yeah, let's say
Interface.
yeah, so this is I think 1.2. Yes, correct. Let's see whether this is 1.2, correct. Okay, let's say we will change this one 1.2. Already it is there, one of the scenario. Okay, so let's see, fill with the color. I'll say red. Means this guy should be blocked. Okay, and what other scenario? 3 network should not communicate to your 2 network. Means when this network is trying to communicate with this network, should be blocked. And here, when this PC, only this PC, when it's trying to communicate with this network, should get blocked. And remaining this PC, they should get communicate to all the PCs. And even this PC also should communicate to these guys. All PCs should be able to communicate to this network. Even they people can have access to this network. They can also communicate to this network. Understood, guys?
Yes.
Okay, so now right now I'm in router 1 now. So do show IP interface brief. Okay, so now all the interface is up now. So what is the first job we should do, guys? So let's configure the static routing. Fine. So do you remember, guys, static routing, how we should configure? Anybody can help me out? Who will help me?
I've forgotten.
Okay, let's show you the
mention your networks in the side of that router.
Yeah, so what I will do, guys, this time I will show you the very simple way to configure the static routing. So let's go to static. So which network you want to reach? I want to reach to 192.168.2.0 network. Okay, what is the mask for this? 255.255.255.0. Who is your next hop? 10 dot, right? 10.1.1.2. Correct? Add. We can see, right? Automatically it will form your command. No need to type or entire thing. Understood, guys?
Yes.
Yes.
Okay, same thing for other network as well. That is 3.0 network. It should go via same IP, right? Add. Correct? Okay. Now, one more network. Which one? 2.0.0.0 to reach to this network. 255.0.0.0 go via same IP address. Invalid IP address where? Yeah. Done, guys. Anything else we are missing? Is it easy, guys? This is the part of automation, guys. In the future, guys, what are the things you learn? EAGRP, OSPF. So everything we need to configure. Right now, in this packet tracer, Cisco packet tracer, we can do static and RIP. See, by the moment you enter, it is going to the RIP. The moment you enter, it is going to the static. Is it quite very easy, right? And same thing,
Yes.
Same thing will configure this side also. This time we'll configure static routing. So I want to read 192.168 1.0 networks and separate pass key 255.255.0. Go via 10.1.1.1. Add. That's it. And one more is 3.0 network. Go via 20.1.1.2. Add. That's it. Understood, guys?
Yes.
Okay, so now who will tell me for the router 3 now? Anybody?
Networking 192.168.
192.168. Then
.3.
3.1.
1.
Why dot 1?
.0.
Why 3 dot network? You are in the router 3, right?
You don't have to mention that network since it's your network, so you know it. You have to mention the other network that you don't know.
Yes.
Why?
It is directly connected, no man.
That is direct connected to a network, so you know it.
Directly
but you have to
connected,
mention
you
the other.
directly connected. See, I told you, right, while I'm doing it. Last time I told you, in the static routing, when you want to reach to this network, okay, and this network, and this network, how many are there? 3, right? 1,
Yes.
2, 3. In terms of your router 3 perspective. Directly connected network, no need to do any routing protocol. By default, it will communicate to this IP address, this interface, it will communicate, even this network also will communicate.
Yes.
Understood?
Yes.
Yes.
Okay. So now you tell me how I should configure now. I'll show you the topology. We can see on the screen, right? Who will tell this?
192.
Okay, 192.168.2.
.2. .0.
Okay, good. Then mask 255.255.255.0. Go via which IP? This interface, right? You can see on the screen this interface. That is 2.1.1.1. Correct?
Yes.
Add. Done. And one more is 192.168 1.0 network. Go via same. For this. For this I'm talking about. For this one, guys. Go via this IP address. And one more is this one.
1.
Got it? Add. Okay, and one more is 10.0.0.0. Okay, 255.0.0.0. Go via the same IP address. Is it the IP address correctly we have given, man? Check, I think. Do show IP interface brief. Oh man, we have given 20 network. So this is my router R3. Correct. And what is IP address here we have given? Do show IP interface brief. So here also we have given 10 and 20. But we configure what wrong, right?
Yes, we configure one of the networks.
Supposed to be 2.
It should be 20. So what we should do? So go to static. Okay. Remove this all. I think 10. This is
remove only one.
One. Which one? 2 network.
2 dots. Yes, 2.0 network.
Okay. So go to physics. Yeah, physical. static. Okay, 3 network. This is correct. Go via 10.10.1 is correct.
Yes.
So only thing is this guy. See, this all thing we should remove. Correct?
Correct.
Yes.
Wrongly we configured. Okay, so we will learn from mistake, guys. Okay, so even I do mistake, right? Sometimes. No one is expert in the IT industry, guys. Remember. So 192.168. Okay, to reach to 2 network, go via 255.255.255.0. Go via 20.1.1.1. Correct?
Sorry, sir, why are you writing 20? Sorry. Can you show the topology? This is 2.
This is 20, guys.
Okay.
This is 10. It is my mistake, man. I did that one.
Okay.
Okay. And one more is one network. This is my one network. Go via the same network. And last one is 10.0.0.0, 255.0.0.0. Go via the same IP address. And that's it. So now I think they should learn, right? Can you check static routing? How to check static routing? Do show IP route static. You can see, right? All 3 networks we can see here. And let's say the middle one, show IP route, show IP route static. If you are in global configuration mode, please guys, please type do show. So this guy also learned. And let's check the last guy, router 3. So do show IP interface brief. So this guy also learned, right? We can see. So 3 network. E type show IP route static. Yeah, so this guy learned 10 network, 1 network, and 3 network. So I can able to communicate from any one of the PCs, guys here. So I can ping to say 192.168. So 168, 1.2. Under 2 is there, right? Anybody IP address? Who is 1.2? Yeah, this guy is 1.2. 168, 1.2. He is 1.3. 1.4. Why I cannot ping to 1.2? So ping 192.168, 1.2. What is the problem, guys? We can see the routes, right? Show IP interface brief 2.2 is this interface is up. Yeah, so this both are up, no problem. This is 3.1. So check the IP address for this guy. Show IP. Do show IP interface brief. Yeah, these all are up now, no problem. Let's check this interface. Do show IP interface brief. So 1.1, 3.1, fine. So no problem with the IP address. So now why this guy is not pinging? Let's ping to gateway. 1.1. Let's ping to 10 network. Davara, can you tell me what is the issue? Why is not pinging? I can see the routes, right? Show IP route. He has learned one network via 20.1.1.1. Who will tell this one? Guys, are you there? Why is not getting communicate? We can see all the routes. Clara, Angie, Gavara. Check from this side.
Did we confirm the configuration on router 1 for the interfaces, the IPs on the interfaces?
So this is my R1. Do show IP interface B.
Okay.
Show IP route. So this guy has learned 3 network and 2 network. The problem is here. Show run.
Yes.
Yes. See, we have configured with 2 network. Right? So copy, just remove that. So no, paste. So now IP route. So to reach to 20 network, 255.0.0.0, go via 10.1.1.2. So now I think I should be able to reach. Can you see here? 10 network. Yes, that something we are missing. Let's check this one. Show run. 10 network we configured. Perfect. 1.1.1. Oh, why? How come this RIP? I not configured RIP, right? Go to and how come this configured with the RIP? Remove that. Okay, no router RIP. So let's configure this very simple way. So IP route. So to reach to 192.168.2.0 network 255.255.255.0, go via 10.1.1.2. Okay. And another network is 3 network. Okay. And another network is IP route 20.0.0.0 255.0.0.0, go via 10.1.1.2. Show IP route. So let's check now. Now I think it should be able to ping. 1.11. 1.1 is there or oh, it's a 1.0, man. Yes, I'm pinging wrong IP address. Nobody is, you are sleeping, all of you guys. You all people are sleeping in Malawi and Tanzania in Africa. You are enjoying weekend because I'm fasting here. I'm training you guys. I'm pinging to wrong IP address. See, now it's pinging. Perfect. I think all are sleeping. I think only Clara is active.
Oh.
Who is active now again? Okay, so now everybody has communication. I'm sure about it now. So let's put it to the PDU now rather than doing this thing. So let's say this guy is pinging to this guy. Why it's failure? Is it IP address they have given? 192.168.3.1. So ping 192.168 3.1. What is the problem, man? Show IP route static. See, now we can reach all the network. It is reaching, but thing is, we cannot able to ping. What is the problem, man? Can you ping to that guy from router? So ping 192.168 3.1. Yes, I can reach 3.2. I can reach 3.3. 3.3 is not there. 3.4 is there. Okay, we can reach it. So how come this guy? Let's check this guy. This is 1.3. So let's put it PDU to this guy.
Yeah, a little bit faster.
Huh?
Yeah, a little bit faster because the diagram, you're just clicking .3, .2 to do wow. A little bit faster. Sorry.
So ping 192.168 3.1. So I cannot ping to that gateway as well. From router to router, we do have the communication now. No problem with communication with router to router. The problem is check the IP address 192.168 1.3. Fine. This guy 1.1. Maybe 1.4. So can they ping to his gateway? Yes. So can they ping to this PC? What is the IP address for this server? 2.1. 2.1 this guy. 2.2. 2.3. Check the interface. Okay. Let's ping to this guy again. So what is the problem, guys? Why is not pinging? Can they ping from router? Say 192.168. So example 1.2. The problem with what we'll do means, so we'll go to that switch show IP interface brief. This is the escalation part, guys. You must do it. Okay, what I'm going to do, I will go to the interface. The interface gigabyte 0/0/1. I say shutdown. Again, no shutdown. Okay, so same thing, I will do it here. Interface gigabyte 0/0/1, shutdown interface, and give the no shutdown. It's not recommended, guys, shutdown and again no shutdown in the production network. So I don't recommend for you to do the same what I did now. It is not recommended, guys. Show IP route. So I can reach to one network. Number 2. There's a problem with the IP address, guys. I think 192.168. Correctly we assign. Check, guys, what is the problem? 1.4. Interface is up, network is up. Show IP route. static, 3 network, 2 network, and 20 network. So you can reach to 192.168 p.1. I do have the reachability, but why is these PCs are not pinging, man? Let's check with these two. Yeah, these two, they have a communication. Yes, they are communicating. What about these guys? Something problem. Show IP interface brief. Check as per the interfaces did be configured.
So what about the interface on the router 1? Geo 0/0/1.
Show IP interface brief. So this is the router 1. This is fine, no problem. This is my R2. What is the problem? Everything is perfect, man. I don't know what is the issue. So I will do one thing. I will configure the DHCP in router 1. Let's see. DHCP pull HR a network. So 192.168.1.0.255. Okay, so default gateway is 192.168.1.1. So DNS will do this. And that's it. So now let's take automatic IP address rather than static. Yeah, so he's getting now an IP address as per so let's check now. This guy should communicate now. Huh?
Can we run a trace route to see the hops, to see where it's failing?
From where?
From the PC.
Let's say I can reach to 1.1, which is my gateway. Okay, so I can reach now. I can reach up to 2.1. What is the IP address for this gigabyte 0/0/0 and not 2?
Oh, that's the problem. It's supposed to be 10.0.0.2.
10. This is the problem.
Yeah.
Yes, yes.
And the serial one as well is supposed to be 20.0.0.1.
This one, right? Yes. That's the reason why it's not coming. Okay, so interface gigabyte 0/0/0. Okay, so what is the configuration we made here? Show run. See, we configure with 10.1.1.2.
Oh.
See IP route 10.1.1.2. If you type show
Okay.
IP, yeah, show IP
Then it should work.
brief. So here we have changed the 001.
Mm-hmm.
Yes. Means we'll change this one itself. Right?
Mm.
So here what we'll do, interface gigabyte 0/0/0. Okay. So IP address 10.1.1.1 255.0.0.0. Done, right?
Yeah, okay.
And here
We need to change the,
only
let's
one
check
route.
the routes as well.
One route. Okay. Do show IP route.
Mm-hmm.
Do show run. So what we need to change only one thing. So what is the IP address we have? 1.1.1.
Okay, that should be like that.
Is correct, right?
Yeah.
Okay, let's see now. I think it should work now. Yes.
Yeah.
Now they have the communication, right? Perfect. Now even this guy also they can communicate. First packet will be dropped because of the R function. So now they have the communications. So of course we got it. We did it.
Yes.
Plus, it's a small mistake, right? It's a small mistake. Wrong IP address. Means you are not that this shows that you are not following me. As simple as this. I am putting a lot of effort, guys. From India, I am teaching you this CCNA training. This is advanced CCNA. This is not old CCNA. What I am teaching you means you are not following me. Even though I teach like DOJ Tiger, also you people say yes. Okay. Davara, man, where are you, man? You're not helping me. Yes, I think you are very busy in Tanzania.
No, I'm still at work now.
You are back now.
Yes.
I asked a question. I'm asking you help. You're not helping me.
Sorry. I was out here.
Okay. So now objective is 1.2. So 1.2 should not communicate to which two network? Which this guy. Right now he can communicate. Right? Can you see? So this network can able to communicate to other network. The objective is I should block this PC. So what is the objective, guys? For this one, if you want to block, okay, to this PC, first remember your standard access list should be configured nearest to destination. Remember, guys, nearest to destination.
Yes.
Remember, guys, it should be configured nearest to destination. So how do I configure, guys? Destination is, it should configure which router? Router 1 or router 2 or router 3?
Router 1.
Router 2.
Objective is, okay, this PC should not access this network. When it's trying to access this network, it should get blocked. Dawara, are you there?
Yes, I'm here.
Yeah, Dawara, I think, tell me, which router I should configure? I am going to configure the standard access list. Okay.
You should be configured the middle router.
Middle router. This is my R2 because this is my destination. So this is my destination. When this guy is trying to access this network, he should get blocked here.
Yes.
Okay. Now you tell me, you have the idea about what is inbound and what is outbound.
Inbound for incoming traffic.
Yes, the traffic which is coming to the router. Okay, the traffic which is coming to the router is called inbound. The traffic which is going out from the router is called your outbound. Remember, guys, this I'm going to explain you guys now. This I'm going to do the lab now. Okay.
Sorry, sir. Sorry,
Yeah.
sir.
Yeah.
What if we configure to the router 1?
See, the condition of the standard access list is, okay,
Near to the
you should
destination.
configure near to destination. Destination is this, right, for him. When this guy is trying to access this guy, he should get blocked. For him, he is the source. And this network is destination. Understood?
Yes.
I understood.
Okay. Yeah. So let's configure this. So let's open my R2. So what I'm going to configure access list. So if you give the question mark, it will show you 1 to 99 and 100 to 199. Okay,
Yes.
right now we are configuring from your standard access list. So let's say I'll give 1. Okay, I want to deny.
Right.
Okay, I want to deny which host.
We deny the
If I give question mark, it will ask you. I want to deny single host. Okay, single host. What is the IP address of that host? 192.168.1.2.
Yes.
Got it?
Yes.
Yes.
That's it. Okay. Then access list 1 permit any. Because this command is very important because let other guys should communicate, right?
Yes.
Only this guy we have denied to access. Only this guy is trying to access this network. We are going to block it. What about this guy? When this guy is trying to access this network, they should allow, right?
Yes.
Sorry, sir.
Yeah.
What if we didn't we didn't write anything, permit any, that the controls block all other PCs to communicate with the destination 2?
Access list 1 permit any. Apart from this IP address, permit other guys to access the network.
Okay.
Only one guy.
I understand.
Yeah.
My question is that what if we do not write this code?
Means if you don't write anything, this entire network is going to block.
Oh.
Very carefully, very powerful ACL. ACL, guys, remember ACL also can be configured in your Palo Alto firewall, Checkpoint firewall, your Fortinet firewall, your Supers firewall, HP, Dell, all the firewalls you can configure the ACL. Right now we are configuring on Cisco router, Cisco ISR router. ISR router means Internet Service Router, guys. Okay, so now what we have to do? Now we have to apply. Just we have created the ACL. So now we should apply to the interface. So now you tell me which interface we should apply. We should apply to your gigabytes. Let's say interface gigabyte 0/0/0. Okay, IP access group. What is the number we have given? 1, right? 1. Okay, give the question mark. Whether you want to configure the inbound or outbound.
This one is
Inbound.
Is the inbound or outbound?
Inbound.
How, man?
Inbound, sir.
Inbound.
Yes, because it's coming to the router.
Okay, fine. Say example, this is Andrew PC. So I want to deny Andrew PC when he's trying to communicate our company network. Okay. When the packet is coming, okay, it's traveling to this R2 router. Okay. Now this is inbound, right? This is
Yes.
in. Okay, now
Yes, it is
he's
in.
going out. He's going out. This guy, Andrew PC, is going to block. Is going to access to in. Means outbound, right? Is going out from the router. When the packet is going out from the router, that is outbound. When the packet is coming inside to the router, we'll call inbound.
Inbound.
Means here is packet going out, right? Going out, right? Going out to access any one of this PC. Understood?
No. Why? Because it's just knocking. Knocking, open the door, just entering. Why it is out?
Okay, when you apply to this interface, because when you apply to this interface, then it is outbound. When you are applying for gigabyte 0/1, it is outbound. Here it is inbound. Sorry. When you are applying for this interface, it is inbound. When you are applying for this interface, it is outbound.
So according to the rules, the nearest destination it will be gig interface 001.
Yeah, because actually what I did, so it should be here inbound. You are correct, guys, because I thought it is a 1. I should take 1 here, but remember, guys, it's not recommended for your WAN link. This is a WAN link, right? And this is your LAN link. It is not recommended to configure your LAN link, guys. Remember. So let's do that. Okay, so right now I'll take in. That's it. The command is done now. And show access list. The command is to check show access list. Fine. Now we'll check the verification now. Okay. I'll go to the PC now. Any one of the PC. Now let's check. So what is IP address for this guy? This guy is 1.3. So ping 192.168.2.1. I'm getting reply, right? This guy is no problem. Okay, what about this guy? So ping to 192.168.2.1. Okay, I can reach it. So check this guy. So ping. Okay, is getting blocked. Can you see? Destination host unreachable. This is your standard access list. Means red PC, I have blocked it. And this guy they can able to communicate. You can see, right? Okay, no packet lost. So only this guy, we have blocked it. Understood, guys? So even from this PC, but he can communicate to 3 network, let's say 3.1. So why the 3.1 also he cannot communicate? Right. So what we should do, guys, go to this router. So go to that interface. Okay, interface gigabyte 0/0/0. So no IP access group 1 inbound. Then go to gigabyte 0/0/1. The IP access group 1, that is outbound. And right, show IP access list. So now let's see. Now this guy should be able to communicate to 3 network. Yes, perfect. Because guys, as I told you that, so it's not recommended to configure for the WAN link as ACL. Remember this. I think IP access group we have given. Just we have changed the interface. Just we have SAP, we need to change that IP address, then it will get blocked. So what is the one more condition, guys? You can see, right? 3 networks should not communicate to 2 network. Means this network should not be able to communicate with this network. We should block. Now you tell me where I should configure this. In router 2 only, guys. In router 2 only, you should configure your ACL. So what is the command I should give? Very simple command. Okay, show IP access list 1. Access list only. Access list 1. Okay, so what I should do? Deny 192.168.3.0 network and give the wildcard mask. That's it. Okay, so this is how we have to configure that. So if you check now, so we should apply to the same interface. Okay, interface gigabyte 0//1, I think. Yes, it's 1. Okay, so IP access list 1, it is when it's going out, you should get blocked. That's it. So I think they'll not communicate with each other. Let's say this PC to this PC. What? Man, very success, man. It's communicating. We should get blocked, right?
No, there are, because you're defining the one access list with the 2. You need, I think you need to differentiate the access list 1, access list 2.
No. We can put it in one single access list. See what it did. Show run. Okay, access list 1, deny 1.2, permit IP any. File list 1, permit 3 network. Okay, so then what we did, and again we enter into the gigabyte interface 1 outbound. When we are given, it is a 15 IP access group outbound. Is it
Inbound.
correct? Yeah.
Sorry.
Sorry.
Can you show the diagram?
Yeah.
Network 3, 92.68.3. If it goes to network 2, means it is going to interface 0.0.0.1. So
Okay.
this will be inbound. We configure outbound.
This one. It should be.
Yes.
It
inbound.
It should be inbound, or it should be outbound, no man? See,
inbound.
When this network, okay, when this network is traveling, okay, coming inbound, okay, we have configured this as an outbound. Okay, when coming out, it should get blocked. There is outbound. We have configured correctly, no issues. So let's say right. Show IP access list. Yes, access list 1 matching is happening. Deny host 1.2, 15 matches. 33 dot network wildcard mask. And show interface gigabyte 0/0/1. 1, right? Yeah, it's 1 only. Let's ping to this network. So 192.168.2.1. Oh, why, man? Let's do one thing. Okay, so I will save this all configuration. Configuration is correct, guys. No doubt about the configurations. I'm confident that the configuration is perfect. No problem. Okay.
There's a problem, sir.
What was it? Okay.
Little, slow. Because when we communicate from network 3 to network 2, the interface of 001 will be inbound to access the outbound of network 2. So we configure the outbound, not inbound. We deny the outbound instead of inbound.
Just give me 1 minute.
Okay.
Sorry, guys, some interruption now. Okay, let's open that again. It will work, guys, because we did a lot of lab for ACL. So let's check this guy. Show IP access list. So let's increase this. So let's see. What happened, man? Why is it pinging? Standard ACL. Okay, guys, I will do one thing. I will send you this file. Please check your side so that we can jump for your extended access list. It will ping us. Everything is fine. Something we are doing some mistake. Okay. Let's see what is the issue. One network, fast Ethernet. Here is the gigabytes Ethernet. Huh? Okay, let's configure once again this. So go to global configuration mode interface, gigabyte 0/0/1. Okay, so IP access group 1, it's out. So let's see now. Oh, these guys. So this guy got blocked. What about this guy? Yeah, this guy got blocked. This side is working perfectly. Yeah. This side is working, only from this side is not working. So we'll see, guys.
So I'm not sure if at a certain time we removed the static and used the DHCP.
Okay.
If we can check on that router, on the switch, I think. At a certain point, you wanted to do the DHCP.
The one.
Conflict. Okay, see IPD, sorry. Conflict T, IP, DSCP, DSCP, I think HR, I think. So IP DSCP exclude 192.168.1.1. So you want me to configure DHCP here? There is not a problem, man. We have got the IP addresses all. They have the communication, no issues. Everything is working fine, no issues. Show IP route, static configuration we made, static routing is working. So they have the reachability now. Okay, I can reach to one network and two network, even like 2.2, I can reach to 2.3. Yes, I do have reachability. DHCP is not an issue. It is working. So let's say we'll configure once again. So go to global configuration mode. So no access list 1. Removing is very simple, guys. Then same thing here. 1 no IP access group 1 outbound. Only typing is little bit difficult. So do right. Okay, so I'm going to configure this thing, guys. So let me explain. So clear IP route. If there any route, it will remove it. Show IP route. Let's configure the right from the scratch, guys. I'm going to configure the ACL, standard ACL. So ACL, I'll give, say example, I'll give 20. Okay, so I want to deny say 192.168.1.2 without any wildcard mask. So this way also we can give. Okay, or we'll deny one more PC. Okay, we want to deny host 192.168.1.3 this time. 1.3, that's it, to deny that. When this guy is coming to our 2 network, okay, so we should get blocked. Okay, then access list 20, deny 3 network as well. 3 networks with any wildcard mask. In the wildcard mask. Okay, then access list permit IP we are not given, man. Access list 20 permit any. Okay, now we have to implement now. Okay, so where we have to implement, guys? We have to implement in your gigabytes interface, this interface. We have to implement in this interface. Okay, so interface gigabytes 0/0/1. Okay, I have entered the interface. So IP access group. Okay, and give the access group number which we have created 20. Okay, now it's the inbound or outbound. So as per this thing is, it should be the outbound. Okay, so now do right. So first check this PC. So ping to 192.168.2.1. What is the problem, man? So let's check from this PC. Guys, who will help me, guys? Dawara, are you there? He's getting communicate, man. We want to block. We are the network security engineer now. We should get blocked, right? Let me check the 192.168 2.1. Everybody is communicating with each other, even though we applied ACL. Guys,
Yes.
what is the issue? How do we escalate this issue, guys? How do we do this issue? Everyone is communicating. So what we'll do, guys? So let's remove this. Say no. Okay. So now what I will do?
Change it from in to out.
This time I'll go inbound. Do right. Let's see what happened. Still they have the communication. Let's say this guy. Still they have the communication. Means inbound, technically speaking, is not correct. It should be the outbound. So this time what I will do, guys, just I'll remove that. Okay, let's give for this WAN interface. So interface gigabyte 0/0/0, the IP access group 20 and is coming inbound. Okay, same thing for that side. So interface serial 0/1/0, IP access group 20 is inbound. So let's say now. So now he's getting blocked. Okay, this guy is getting blocked now. Let's say this side fail. So these people cannot communicate to this guy. Now it's working. Means we have to give separate. What I did, just I applied to this interface, guys. What I did, so rather than conferring to this interface, I configure this as a inbound traffic. When packet this guy is coming to access this guy, he should get blocked here. When this guy is coming here I applied inbound.
Sure.
Understood, guys? Okay.
Yes.
I hope this is clear, guys. I think tomorrow we'll continue with your extended access list. Extended access control list. Very important topic, guys. We'll call ACL extended. So this lab will do it tomorrow, guys.
Okay.
Okay. Thing, guys, so please try to join because I have sent almost, I think, 60 people. Any few people has been joined. And anyhow, tomorrow we'll start, ask them to join for this extended access list.
6016. I think the Malawi boy has got the power problem.
Ah, okay.
Okay.
Power problem. What about other guys? I think Asma, you are following, right? Akila, Sahil, Gani, Isaac.
Yes.
So even I am live. Those, if they are not following us, please tell your friends. I'll be live in YouTube. So
And
those
also don't forget to share the slides, PowerPoint slides.
Ah, so you want powerful slide, right? Okay. Okay, I will share that.
I think they will help.
So this lab also I'll share you guys.
Yes, do that.
Yeah, so let me share you that. So I'll share you both the commands and what are the commands I used it. Okay, so you can able to do from your side. Guys, do every day, guys. I'm sending you a lot of labs, commands every day. I'm sharing you, right? If you don't practice means, guys, you can't understand, guys. In coming lab, guys, so every day you should practice. If you don't practice means, so I'm sure I think nobody can understand anything.
Sure.
So I think regarding the slide, I think I need to download. So I think I downloaded it. Someone has written day 4. It is my chatting. Guys, we can see, right? So we can able to CCNA 4 and I think this is the YSPF. Both I have sent you guys, YSPF and this thing. Asma,
Yes.
Asma, Claire, are you there? I think she has joined, she has quit. Okay, guys. So we'll stop the session now. And we shall continue tomorrow.
Thank you. Be blessed.
Thank you, guys. Okay, and
Thanks,
guys,
you too.
if tomorrow try to join, ask them to join. I think most of the people, I don't know why they are joining. Almost 60 people, they are registered. I don't know what is the reason why they are not joined.